Dear students, I am Mahesh Javalkar from Maratha Polytechnic, and today we'll start with our new subject, analog electronics, in which we will start with the regulated power supplies. Okay. Now, the first point here is what is a power supply? Okay. A power supply is one which will give you output power. Output power. Now that you can take it in terms of voltage or current, and that you can use it for your appliance to work. A certain application can work on that. Okay. Then what do you mean by regulated power supply? A regulated power supply is one where the output remains constant even if the input line voltage varies or if the load varies. Even if the load varies or even if the input line varies, in spite of both these conditions, the output of the power supply remains constant. That is what is called as regulated power supply. Okay. So in this first chapter, we are going to study what are these power supplies and what is this regulated power supply. So in the first point, we are going to study what is a regulated power supply. Okay. Now, as a general statement, we know power supply is something which we use to energize a circuit and to give a application. To complete an application, you require a power supply. The first point in any electronic circuit is power supply, and that power supply should be correct. Okay. Now, in the electronic circuits, whatever we are having, okay, most of the electronic circuits require around 5 volt supply. Okay. So, because this supply should be exactly 5 volts, it should not be more than 5 volt or it should not be less than 5 volt. It should be exactly 5 volts. So a normal power supply will not work here because normal power supply can change its output when the input line voltage varies, when your 230 volt which comes from your main plug that can vary, or when the output load what you put for that appliance varies. In that case also there will be a variation in the power supply output. Okay. So for both load and line regulations. Okay. So here we require a correct power supply, and to have a correct power supply of a specific number, say around 5 volt, then you require a regulator. A regulator will be a circuit which will see that the output of the power supply is remaining constant at a specific value. Say, for example, 5 volt at a specific value. It will not increase or decrease from that value. It will remain constant in spite of there is a variation in the line or there is a variation in the load. Okay. So that is what is a regulated power supply. So first question comes to our mind is why do we need regulated power supply? And for that, this is only the reason because most of the electronic applications require a correct and constant power supply. Otherwise, they will malfunction. Otherwise, they will not function correctly. So we require a correct regulated power supply. Okay. So next we'll go to see the next slide. That is the first slide. So in first slide, I have written what are the outlines of this presentation. So first point what we'll be studying will be need for regulated power supply. That is why do we need a regulated power supply. Second point will generally define what is a regulated DC power. Third point we will see block diagram of regulated power supply. And fourth point we'll see stages of regulated power supply. Okay, what are the stages involved in the regulated power supply? So let's start with the first point, need for regulated power supply. So as I've told you earlier, key for every electronic application, the voltage source required will be constant. That voltage source, that power, whatever is required is constant, and that should not vary even if the line that is the main supply varies, or even if the load varies, or the load or resistance varies. Okay. So in both the cases, it should remain constant. That's why it is called as regulated power supply. And that is why we require regulated power supply in today's electronics world. Okay. So here I have given a note. Okay, so here you can see the question is asked is why we need DC regulated power supply. So here what I have written is everywhere in world an electricity is available in houses and industries in the form of alternating voltage. Okay, that is the AC. The AC main supply has a voltage rating of 230 volt or 120 volt root mean square RMS at a frequency of 50 hertz or 60 hertz. It is 50 hertz in India, and in some foreign countries it is 60 hertz. Okay, that is a frequency. Nowadays, almost all equipments in houses and industries include an electronic circuit. Okay, obviously we see everything is controlled electronically nowadays. Okay, even if you are having a washing machine, or even if you're having a microwave, or anything you have, it is electronically controlled. Most of the appliances are electronically controlled. Okay, the electronic circuit uses semiconductor components and devices which require a stable DC voltage for their operation. The batteries cells cannot be used because they are costly and inconvenient to use. Okay, everywhere you cannot use batteries or cells because that will work out to be more costlier and it is not inconvenient. So it is necessary sometimes, it is necessary most of the times that whatever available AC voltage you have from the main supply, that should be converted into DC voltage. So whatever you get AC supply from your main supply, that is your main supply at your home or at your industries, whatever you get AC voltage, main supply 230 volt or 120 volt, okay, that should be converted into DC and then it can be used for operation of electronic circuits. So then there is no there is no work of any battery or cell what you have to use. You can directly take the AC mains and convert it into DC and use for your electronic circuit. So this is what is the main requirement in today's electronic world, and that is why we require DC regulated power supply. Okay, so this equipment which converts AC voltage into pure and stable DC voltage is called a DC regulated power supply. So this is a general statement why we require DC regulated power supply. Then if you conclude that, we can also tell that a fluctuating DC voltage may result in an erratic operation of electronic devices and circuits. Okay, that means whatever the source of DC voltage you are going to use for electronic circuit, if it varies, then the electronic device and circuit can operate differently. They will malfunction, they will not function according to your desire. So it is an erratic operation. Okay. Then, in order to avoid poor voltage regulation due to fluctuation in DC voltage, it is necessary to use a voltage regulator circuit in DC power supply. Okay, so to avoid poor voltage regulation due to fluctuation in DC voltage, so to not have any fluctuation in DC voltage, if we want a constant DC voltage, then we have to go with a regulator circuit in DC power supply. Okay, so we should not use a normal power supply. We should use a regulated power supply. That is why this a topic of a regulated power supply. Okay, then we'll go to see the block diagram of regulated power supply. So here you can see a general block diagram of a regulated power supply in which the first step is the AC mains. So here you can see the AC mains. So this AC mains can be your 230 volt, okay, and 50 hertz supply, which is AC, which will look like this: positive half cycle and negative half cycle. Okay, then here you are having that is given to a transformer, which can be a step down transformer. So here you can have a circuit of a transformer. So here you can see the primary winding, the secondary winding, and the voltage will be stepped down because electronically we don't require 230 volts. So 230 volt can be converted say into 6 volt, 7 volt, 10 volt, 8 volt, 5 volt. Okay, so anything can be converted. So it can be stepped down of your AC voltage. Then you are having a rectifier here which will convert AC to DC. So here AC will be converted to DC, but here whatever DC you get will be a pulsating DC. It will have some AC component in it. That AC component has to be removed and you have to make it a pure DC. That can be done by a filter. Filter will take a pulsating DC here, pulsating DC, and it will convert it to your pure DC. Okay, pure DC. Okay, so then that pure DC voltage is given to a regulator circuit. Now this regulator will see that that voltage remains correct constant at the output. This voltage remains constant at the output. It will remain constant at the output, constant output, in spite of your having input line variation or output load variation, and then it is given to the output circuit. Okay, then it is given to an application here. So there you can see you can give this to an application, a constant voltage, constant output voltage, okay, is given to the application. Okay, application. This is what the general working of a regulated power supplies. Now, if you see the same diagram with the waveforms, okay, what is the AC waveform in the beginning, then what is the waveform after the rectifier, what is the waveform after the filter, and what is the waveform after the regulator. So you can see this diagram over here. So here you can see from AC lines, you're going to get the input, and the input is given to the transformer. So here you can see this input is given to the transformer. Okay. So this input you are going to give to the transformer. So here you can have 230 volt, okay, 50 hertz input, and that will be a alternating quantity. Output of the transformer here also will be a alternating quantity. You can see this plus half cycle and minus half cycle, again plus half cycle. So it is a alternating quantity. It is AC quantity. Okay, only thing what will be done here in the transformer is there will be step down voltage, step down of voltage. If the input is 230 volt, output can be 5 volt. Okay, so you are stepping down the voltage by having the number of turns in the primary and secondary appropriately. Okay, so number of turns in the primary will be more and number of turns of the coil in the secondary will be less, and then output of the transformer will be a reduced voltage one, okay, at the same frequency. Okay, so that alternating quantity here also you'll be having a alternating quantity that will be given to a rectifier. A rectifier has to do this alternating quantity, it has to convert into DC. Okay, so it is made up of a diodes in which you can have a half wave rectifier, full wave rectifier, and generally we use here full wave rectifier. Okay, so here you will get only the positive half cycles at the output. So here you will get only the positive half cycles at the output. It will be a unidirectional output, it will be a DC output, but it is called as a pulsating DC. This is what you can see here. Okay, so this output is given, it is all plus half cycles you'll get. It is a unidirectional, it is a pulsating DC. This is a pulsating DC, it is not a pure DC. Okay, now this pulsating DC has to be converted into pure DC by a filter. So this is a filter which will convert this into this type of waveform. Okay, so it will become a pure DC. It will not become exactly straight line, but it will be a charging and discharging of a capacitor. Okay, so here you can see it is a DC or whatever you get. Okay, now that DC, pure DC, should be converted into a constant voltage by the regulator. So this regulator is there which will convert that pulsating DC. Now this pulsating DC should be converted like this. Okay, that is a constant line. So here you can see a constant DC. This is a constant DC. This is a constant DC. So that will be done by the regulator, and then it is given to the application, which is the load, which is the load. That means the load will get a constant DC voltage because of the regulation of the power supply. A regulator is used in the normal power supply. So you get a constant DC voltage in spite of variation in line, that is the input, or in spite of variation in the load resistance. Okay. This is how you can explain the block diagram of regulated power supply. Now, in this block diagram, whenever you are going to write or explain on this, you are going to take the one stages of the block diagram separately. So first is what we know is we give input of AC mains to the step down transformer. Okay. So here you can see, first you see the definition of DC regulated power supply. The regulated power regulated DC power defines a DC power supply which maintains the DC voltage constant irrespective of AC input fluctuations. This is very important. Irrespective of AC input fluctuations. So here you can see this word is important. AC input fluctuations or this load resistance variation. Okay, so any of this varies, the output voltage should not vary, it should remain constant. So that is what is called as regulated power supply. Okay, then we'll go to see the stages of regulated power supply, what we have seen in the block diagram. In the block diagram, we have seen the first unit as a step-down transformer. So we know that a transformer is a circuit which will transfer power from primary to secondary without having an electrical connection. It will be isolated in between, okay? But it will transfer on the basis of electromagnetic induction. And in that, we are using a step-down transformer. That means the input voltage will be high and the output voltage will be less according to our application. Then second one, we have a rectifier which will convert that AC voltage output of transformer into a pulsating DC. Then we have a DC filter which will convert pulsating DC into a pure DC. And then we have a regulator which will see that the pure DC is remaining constant in spite of line regulation or load regulation. So these are the 4 points what you have to remember when you explain stages of regulated power supply. Then if you see what is a step down transformer, a step down transformer will step down the voltage from the AC mains to the required voltage level. The turns ratio of the transformer is so adjusted such as to obtain the required voltage value. The output of the transformer is given as an input to the rectifier circuit. So it is a transformer which will reduce the input AC main voltage to a lesser voltage value because a lesser voltage value is required by the electronic circuits. Okay. Then if you see a diagram of a transformer, so here you can see the primary windings. So here you can see these are your primary windings, okay, which are winded on a core, and these are your secondary windings. Okay, so here you are going to apply your AC mains. AC mains will be applied here, AC mains, and here you are going to get the uh, here you are going to get the reduced AC voltage, reduced AC voltage. Okay, that means the voltage will be reduced, it will be stepped down. Okay, so here to have a step down, the primary winding should be more and the secondary winding should be less. Okay, so if you see it in a circuit way, the primary coil and the secondary coil will be shown like this. So here you can see the primary coil. So the first part is shown as a primary of the transformer. So here you can see this is the primary of the transformer, and here you can see this is the secondary of the transformer. So these number of turns are more here and these number of turns are less here. Okay, so a bigger voltage, say around 230 volt, can be converted into a lesser voltage, say for example 5 volt. Okay, and this is your magnetic core, and here your magnetic induction takes place, electromagnetic induction takes place. That is, magnetic lines of flux will get in cut by the both the coils. Okay, and that is how the power will be transferred from primary to secondary. Clear? So this is what a transformer is. Then we will go to see what is a rectifier. A rectifier is an electronic circuit consisting of diodes which carries out rectification process. What is rectification process? A rectification process means it is converting alternating voltage AC or current into corresponding direct voltage or current. Okay, that means AC is converted into DC. The input to a rectifier is a AC, whereas its output is a unidirectional pulsating DC. It is not pure DC, it is pulsating DC. Okay. Then most commonly we use a full wave bridge rectifier in a regulated power supply. So here you can see the AC mains is given to a transformer. So here you can have AC mains. This is your AC mains. It is given to the primary of the transformer. Then you have a reduced voltage at the secondary of the transformer. Then it is given to a bridge rectifier. This is your bridge rectifier, full wave bridge rectifier. Okay, in which once this point is positive in the positive half cycle, okay, positive half cycle, then D1 will work. It will go here to the ground point. It will go to the load. Current will flow like this. And while coming from here, D3 will work and it will return back. Okay. Once the other point is positive, okay, in that case, D2 will work. Okay. It will go to the ground here. Then from the ground, again, the current will flow in the same direction and will come back. It will come back here and it will go through D4 to the top line. Okay. So this is how your four diodes are going to use to convert AC into pulsating DC at the output. So here at the output, you can see the current is going to flow in one direction only. So it is unidirectional. Unidirectional. Even if the input is positive half cycle or negative half cycle, the output will be unidirectional. So your output will be something like this. It will be only positive half cycle. There will be no negative half cycles. Whereas your input was here you can see your input was both positive and negative half cycle. Okay. So that positive and negative half cycles will be converted only positive half cycles at the output. This is what the work of rectifier is. That means AC is converted into pulsating DC. Okay. Alternating quantity is converted into direct quantity or unidirectional quantity. Okay. Then we'll see what is a filter or DC filter. The rectified voltage from the rectifier is a pulsating DC having very high ripple content. But this is not what we want. We want a pure ripple-free DC waveform. Hence, a filter is used. Okay, now filter is a circuit which will convert your pulsating DC into a pure DC. That means it will remove the AC component present in the output of rectifier and it will give a pure DC at the output. Okay. Different types of filters are used, such as a capacitor filter, LC filter, choke input filter, pi type filter. Okay, so these all filters will see that the AC component present in the DC output of rectifier is eliminated, is reduced, and a pure DC is given to the output. Okay. So here you can see the circuit or the block of the filter in which the input is been shown as a pulsating DC. So here you can see the input which is shown as a pulsating DC. So here this is a rectifier output. Now this rectifier output is nothing but pulsating DC. Okay. Now that pulsating DC will go through the filter circuit and it will be converted into a pure DC. It will be converted into a pure DC. Okay. Then we will see what is a regulator. Its function is to maintain the output DC voltage constant, irrespective of fluctuations in AC mains voltage and variations in current load. Thus, the regulated power supply gives the stable DC voltage across the load. Okay, that means the output of the regulator, that means the output of the power supply which is having this regulator should be constant even if there is variation in the AC main voltage or even if there is variation in the load current. Okay. Then, depending upon type of regulation, the regulators are mainly divided into two types, namely line regulation and load regulation. Now, say if there is a variation in the input AC main and you are giving a output constant, then it is line regulator. If there is a variation in the output load and still you are giving a output constant voltage, then it is load regulator. Okay. So here you are having two types of regulations. One is line regulation and one is load regulation. So line a regulator, if you see a regulator which regulates the output voltage to be constant in spite of input line variations, it is called line regulator. Similarly, load a regulator, the regulator which regulates the output voltage to be constant in spite of variations in the load at the output, it is called as load regulator. Okay. So here, therefore, to maintain a constant voltage across the load when there are variations in the AC supply or the load current, that is, you want to do regulation, or both the voltage regulation is necessary, The commonly used types of voltage regulators are. So there are various types of voltage regulator circuits. The first one can be your Zener diode voltage regulator. The second one can be your a transistor series voltage regulator. Can be your IC voltage regulators. Fourth can be your SMPS, that is switch mode power supply. So any of these are regulators according to your application you can use to get a constant regulated output. Okay. So any one of will be used for that. Then ultimately at the end, if you see the concluded a diagram of your regulated power supply, so here we see the first point is the transformer. So this will be your main AC supply. This is your main AC supply where the voltage is more. Then it is converted into a smaller voltage, but still it is AC supply. So this is step down process. Okay. The number of primary coils here are more and the number of secondary coils of the transformer are less. So you're stepping down, you are reducing the voltage. Now this is AC only. Now this AC will be converted by the rectifier as pulsating AC, pulsating DC, sorry. This will be converted to pulsating DC. Now this pulsating DC will be converted to pure DC, pure DC by the filter circuit. This is the filter circuit, which is also called as smoothing circuit. Then this pure DC will be converted into a constant voltage, constant output. Okay, in spite of line regulation or load regulation by the regulator. So this regulator will do that, and then it is given to the load, which will be your application, which will be your application. Okay, this is what we have studied in the block diagram of regulated power supply. So you should know first how to draw this block diagram, and if you support the block diagram along with the waveforms, it will be very nice. It will be more understandable, and then on each block you should be able to write a note, that is what is a transformer, what is a rectifier, what is a filter, and what is a regulator. Okay, so students, here we end with the explanation of block diagram of a regulated power supply. Thanks for watching. If you're having any doubts in this, you can ask me, you can call me, or you can leave a comment or below my video. Okay, thank you very much.